Hello and welcome. So today we are trying to find the maximum or minimum of a function using the Lagrange multipliers. So to do that, we're going to need our function f, which is subject to another equation g, which is a constant, which we call a constraint. So basically, to do that, we need to form a new function that depends on x, y, z, and lambda. To get the new function, we take whatever we're trying to maximize or minimize, and we subtract that away by the original constraint after setting it equal to 0, and also multiplying it by lambda. We take the partial derivative of that with respect to x, y, z, and lambda. Doing this, we will get a big system of equation we need to solve. We sub the solutions back into f of x, y, and z, and that's how we get the max or minimum of a function. Here's a word problem for us, just to put it in context. Produce TV sets at two factories A and B. Suppose X TVs are produced at A, Y are produced at B. Suppose the cost is given by C of xy equals 6x squared plus 12y squared. If you must produce 90 TV sets, what is the number that should be produced at each factory to keep the cost at minimum? So to do this, as we said earlier, we take whatever function we need to minimize or maximize, which is the cost function in this particular problem, and subtract lambda but times the constraint. In this case, since we have to produce 90 TV sets, so the TV sets from both A and B should be equal to 90, the constraint would be x plus y equals 90. So we set that to 0 and we put x plus y minus 90. So we get the function for x, y, and lambda. So I'm gonna do this a bit so it becomes simpler. After doing that, we get the partials for x, which is going to be 12x minus lambda, and f of y is 24y minus lambda, for f of lambda equals negative x negative y equals 90 minus 90 plus 90. Plus 90. So then we set the partials equal to 0. Here we get x equals lambda over 12. Here we get y equals lambda over 24. So we take these two and we put them in this guy right here. So after doing that, we get negative lambda over 12 minus lambda over 24 plus 90 equals 0. So we get multiplying. So we get minus 3 lambda over 24 equals minus 90. Which is lambda over 24 equals 30. So we take lambda, so lambda equals 720. So we take lambda and we put it back in 1 and 2. For that we get x equals 720 over 12, which is 60. We get y equals 720 over 12 over 24, equals 30. So we get this answer, 60, 30. Sometimes we find more than one pair, but in this case we only got one pair. So we need to substitute them back into the cost function, which is 6x squared plus 12y squared. So it's 6c of 60, 30 equals 6 times 60 squared plus 12 times 30 squared equals 32,400. And to make sure that this is the minimum, we can do this. We can plug 61, so 61 from A and 29 from B. We can do that. We're gonna get 6 times 61 squared plus 12 times 29 squared. It's gonna be 32,418, which is bigger than 32,400. Thank you guys for logging in today. I hope you learned some stuff, and as always, don't forget to be awesome.